So we're going to start with alkenes. But before starting with alkenes, I'll just talk about some terms that need to be understood, okay? Before we can move on. So some of these terms are related to things that we're going to do. Usmina, the first thing is you need to understand what is homolytic. So what is homolytic bond fission? Okay, that is something that you should know. So homolytic bond fission is that what homolytic bond fission is that the bond breaks equally. For example, okay, if I have a Cl molecule and it's got a pair of electrons, so what will happen with this pair of electron is okay, that one electron is going to go to one atom and the other electron is going to go to the other atom, and your bond will break. And as a result, you will get two Cl radicals. I'm going to talk about radicals later. Abhi फिलहाल just focus on बल्कि ये वाला part. I'll explain that later. Free radicals are formed. I'm just writing it down. So free radicals are formed. At the moment, the only thing you have to understand is, in this case, is that the bond has broken equally. One electron goes back to this one, the other electron goes to this Cl. Is that clear? Homolytic bond fission.
Yes, sir. Yes, sir.
और ये लिख देते हैं bond breaks. Then there's another one which is similar to this. It's heterolytic bond fission. अब heterolytic bond fission is the bond breaks unequally. So as an example, if I have an HCl molecule, and if this bond breaks, both electrons are going to go to one atom. Okay, so that will result in the formation of ions. One of them is going to be H+1 and the other one is going to be ACl-1. So that's going to be a Cl-1 ion. So bond breaks unequally in this case. So remember these two terms. Okay. And then there's a thing called curly arrows, okay, which you can see over here. So what are curly arrows? Curly arrows there. They represent the movement of electrons. How the electrons are moving. And arrows will represent the movement of electrons only. Okay, nothing else. Okay, represent. So you're going to use arrows to represent electrons only, movement of electrons. Okay, where are they going? Okay, they'll be going from one atom to the other one. And there are two types of curly arrows. One of them is a half arrow, and the other one is a full arrow. Okay, the half arrow represents the movement of half arrow headed. Okay, actually, half arrow means a movement of one electron only. Or यहाँ पे ना, this other one, that's the movement of. So this one it represents the movement of, that's a full arrow. So this one represents the movement of two electrons. It represents the movement of two electrons. Remember that as well. जैसे यहाँ पे शो हुआ हुआ है, ठीक है, both electrons, one electron going to one side, one electron going to the other side, that's half arrows, ठीक है. Two electrons going to one side, that's uh, that's a full arrowhead. As a third thing, there's going to be another term that's going to be frequently used, and that's one of them is a free radical, ठीक है. Free radical से start कर लेते हैं. So the first one, that's a free radical. What's a free radical? It's a species, a molecule, or an ion, or an atom. Not an ion mostly. It's a molecule or an atom. ठीक है, atom or molecule with unpaired electrons. That means the outer shells are not complete, and it usually means that they have an odd number of electrons. So it's a species with unpaired electrons. They're very reactive because they're going to try and bond with other substances. ठीक है, so they're going to try and bond with other atoms. So that's why they will try to complete the outer shell. They will try to gain electrons from other atoms. ठीक है, so that's why they are very reactive. ये clear है?
जी सर.
Example Cl, a Cl atom, that's a free radical, right? Because Cl has 7 electrons. It needs 1 electron, so it's kind of very reactive. OH, if it's not an ion, it's a free radical. Its bonds are not complete. ठीक है, कि मतलब even if I draw the OH dot and cross, it would kind of look like this, that there's going to be तो उसके electrons पूरे नहीं है. OH minus 1 is not a free radical, ठीक है, it's because it's got complete electrons, but OH is a free radical. Lots of other things that can be free radicals. For example, CH3, that's a free radical. कि अगर मेरे पास CH3 है ना, that's obviously a free radical because the carbon bonds are not complete. ठीक है, if I draw this one, there's going to be one H over here. अच्छा, one H over here, one H over here. So there's C and H's. And that's a free radical because it's got unpaired electrons. ठीक है, so is this idea clear?
जी सर.
और इसको ना you represent it with a dot. ठीक है, the reason you represent it as with a dot is कि well, it shows the unpaired electrons. So one dot, a single dot basically. बेशक उसके अंदर ज्यादा unpaired हो, but if it's unpaired, it's you show it with a single dot. So that means you got unpaired electrons. Hunayz clear है? Ahmed clear है?
Yes.
Yes, sir.
अच्छा, फिर there's another thing called, so that's a free radical, ठीक है, which is why I was calling कि भाई यहाँ पे free radicals form है. Free radicals are going to get formed when you have homolytic bond fission. अच्छा, then there's another thing called nucleophile. अच्छा, so nucleophile, that's what's a nucleophile? A nucleophile means something that is attracted to positive charge. So, but literally, it means the literal definition is that it's attracted to nucleus. It basically means nucleus loving. ठीक है, so it's attracted to to positive charge or attracted to the nucleus. Iski jo actual definition of that is that it's a species which can donate a pair of electrons. It's not just attracted to it, it's a species which can donate a pair of electrons and is attracted to positive charge. बल्कि ज्यादा बेहतर है species which has lone pairs. इसको तो सही it's a नीचे कर लेते हैं. So it's a species which has lone pairs नहीं एक्चुअली ना ये लोन पेयर वाली बात गलत है. बस यही कर लेते हैं. ये ठीक है. Just anything that can donate a pair of electrons and is attracted to positive charge. Okay, that would be sufficient. So this is what a nucleophile would kind of look like. It's if I represent it with Nu, for example, OH minus 1 is a nucleophile. So OH minus 1 has a lot of electrons. Okay, so if somebody needs electrons, for example, there's a positive ion or something that's positive, then it can donate a pair of electrons. So that's a nucleophile. NH3 is a nucleophile. You've got NH3, it's got a pair of electrons. There's a positive thing, that lone pair is going to get attracted to that NH3 as well. Or CN minus 1 could be a nucleophile. You've got CN minus 1. So this CN minus 1 has, the carbon has these extra electrons, and remember full arrow hai, theek hai, because 2 electrons are traveling towards this positive thing. Who else can be? Water can be a nucleophile. If you have a water molecule that's got lone pairs, so those lone pairs can get attracted to that positive charge. So anything that's attracted to positive charge and can donate, khali attraction nahi, it can donate a pair of electrons. That's what a nucleophile is. Even double bonds can do that. What double bonds will do is that they can be nucleophiles as well. For example, you've got, इसलिए मैं lone pairs की बात नहीं कर रहा था. So for example, if I've got a double bond, now double bond has these extra pair of electrons, and they can get attracted to something that is positive. Is that clear?
नहीं सर, लेकिन ये डबल बॉन्ड तो डोनेट नहीं करेगा ना इलेक्ट्रॉन.
करेगा ना. और डबल बॉन्ड
सर
टूट
तो
जाए. ये डबल बॉन्ड का जो एक बॉन्ड है उसके इलेक्ट्रॉन्स चले जाएंगे.
ओके सर.
ठीक है, तो डोनेट कर सकता है वो पाई बॉन्ड होता है ना, डबल बॉन्ड. ठीक है, सो इट कैन, आई मीन दिस इज यहाँ पे बना हुआ भी था. कहाँ गया ये? This is what I told you, that's how a double bond looks like. Okay, so if anyone needs electrons, ये जो electron cloud है, somebody could take that. I mean, the single bond over here will stay, but the electron cloud will actually go to the other atom जो positive है. ठीक है,
ओके सर.
तो इसलिए वो मैंने हटा दिया था लोन पेयर वाली बात ना. Species that can donate a pair of electrons and is attracted to positive charge. अच्छा,
Sir,
then clear है ये?
the pi bond would break, right?
हाँ, और हमेशा पाई बॉन्ड जो होता है ना, that's the reactive one. जो बाहर होता है ना, वो अंदर वाला जो सिग्मा बॉन्ड है ना, that does not react. अच्छा, अब ये कि एक और चीज है, वो इसका ऑपोजिट है, that's the electrophile. That's literally the opposite, that it's a species that is attracted to negative charge. यानी इस केस में ना X+1 is the electrophile. It's a species that is attracted to negative charge and can accept a pair of electrons. तो it's a species which can, a molecule or ion or whatever atom, which can accept a pair of electrons and is attracted to negative charge. So that's what an electrophile is. तो बस ये और कुछ करना है वैसे. अच्छा कुछ और we'll just you forget it. We'll talk about that later. Hydrolysis and other stuff. ठीक है. So that's pretty much it. Achha, we'll talk about reactions. So I'll just briefly explain. There would be 3 different types of reactions, and you'll give them names. There would be 3 types of reactions. One of them is addition, substitution, and then there is elimination. Okay, so you got 3 types of reactions. First one, मतलब examples ही पता लग जाएगा. Things getting adding. I mean things. If addition is when things just get added up. So for example, if you have this reaction, तो exactly वो math वाली addition है, ठीक है. And there's a Br2 molecule and they all react, and when they react, the bromine gets added to it. ठीक है, H. So now that's an addition reaction. I say you got second one, you got substitution.
सर एडिशन रिएक्शन सिर्फ तब होता है ना जब कोई डबल बॉन्ड हो या ट्रिपल बॉन्ड
Addition, हाँ वैसे तभी होगा वैसे.
ओके
देखो पढ़ेंगे, बाद में पढ़ेंगे. अच्छा, substitution reactions are where one thing gets substituted by another thing. For example, if I have H's attached to it, ये अक्सर वो question में ना, they might give you a random reaction. They'll ask you कि भाई what type of reaction this is. ठीक है, so there's a, let's say there's a Cl2 molecule. So what will happen in this case is that let's say one of the H gets substituted by Cl. और यहाँ पे आपको HCl मिल गया, ठीक है. और finally part C, that's part C is elimination. So elimination is where something gets eliminated. So for example, there's a molecule with Cl. So there's a molecule with Cl, and तो यहाँ पे you get a so there's a thing getting eliminated. ठीक है, so just remember कि what's addition, what does substitution, and what is elimination. ठीक है, there'll be 3 types of reactions: addition, substitution, and elimination. ये clear है?
जी सर
अच्छा, अब आ जाओ कि so now we're going to start with reactions. एक छोटा सा ना बीच में, although this is not a major chunk of your course, it simply means ये मैं वैसे बीच में ऐड कर देता हूँ. It's just that you need to know that the major source of source of organic compounds, that's one of the major sources of organic compounds. That's your fossil fuels. But the living matter, that is all organic, but the major source that you see around you, that's fossil fuels. That's mostly used for energy. ठीक है? अच्छा, और इसमें तो फॉसिल फ्यूल का ना वो डायग्राम एक कर लेते हैं कि उसे क्या कहते हैं, फ्रैक्शनल डिस्टिलेशन ऑफ पेट्रोलियम. अच्छा, ये प्रॉब्ली आपने एएस में ना पहले ही पढ़ा हुआ है, ये वाला उठा लेते हैं. लेट्स जस्ट कॉपी दिस. अच्छा, फ्रैक्शनल डिस्टिलेशन ऑफ, तो ये बस इसका, दिस इज ऑल ओल्ड स्टफ. ठीक है, दिस इज वेयर यू get all your fossil fuels, your bitumen, your fuel oils. इन दोनों की पोजीशन आई थिंक उल्टी की हुई उन्होंने. Lubricating oils, waxes, etc. are at the bottom next to bitumen. You've got fuel oil or furnace oil, ships, factories, etc. Then you've got diesel, kerosene, naphtha, petrol, TK, or refinery gas. So you get all these molecules. Or सारों के अंदर that remember this that small molecules, they always have low boiling points because they have less van der Waals forces. They're light in color, easy to light, which means burn. And runny ka matlab less viscous. ठीक है, उसने ये words use किए हैं. Large molecules, they've got high boiling points. They're dark in color, hard to light, difficult to burn, waxes, etc. And they are very thick as well. अच्छा, ये सारा है. तो ये थोड़ा सा ना आइडिया होना चाहिए. दिस इज वे यू गेट ऑल योर स्टफ. ये इसको एक्सप्लेन करने की जरूरत तो नहीं है ना? इज दैट क्लियर?
जी सर.
Yes, sir.
अच्छा, अब ये कि अच्छा, जस्ट होल्ड ऑन, गिव मी 2 मिनट्स. ठीक है, मैं 2 मिनट में आता हूँ. ठीक है, एक से रुकना. अच्छा, now the next thing is, now we're going to start with alkanes. ठीक है, so we're going to start with alkanes. So what are alkanes? ठीक है, first thing, brief introduction. You've got a thing called alkanes. These are known as these alkanes are known as saturated hydrocarbons. They're known as saturated hydrocarbons. And they have a general formula which is CnH2n plus 2, which normally does not work. ठीक है, but saturated का बस मतलब है single bonds, right? In cyclic compounds, this general formula is not going to work. So I'll draw a couple of alkanes just for reference. Okay, you got carbon atoms, and with H's, this one has H. So they all have and there might be a cyclic structure as well. ठीक है, for example, cyclopropane is cyclic. As a cyclopropane is cyclic, so that's another one. Now, what happens? Alkanes की properties, physical properties. ठीक है, let's talk about physical properties. तो physical properties में कि they're obviously going to have I mean, they're completely non-polar molecules. They don't have any dipoles. The electrons, carbon and H have similar electron negativities, so so they're non-polar, right? And if something is non-polar, then the only attractive force is van der Waals forces. अच्छा हुनैद अगर ये non-polar का नहीं पता ना, it just means के carbon and hydrogen, they pull electrons equally. I mean, they kind of have the exact same electronegativity. So the electrons kind of remain equally distributed between the bond. वो एक side पे नहीं चले जाते. Is that clear? Like one atom is not pulling electrons towards it. The electrons are right in the middle. Hunaid, is this part clear?
Yes.
So what happens is that the electrons are equally distributed in the entire molecule. But sometimes what happens is that ये जो van der Waals forces है ना, that is case. Sometimes what will happen is, for some random reason during a collision, the electrons might get knocked to one side. So that side will become slightly negative and that side will become slightly positive. That's known as a temporary dipole. अगले second वो dipole खत्म हो जाएगा. Then maybe there's another collision and the electrons get knocked to this side. So this side will become negative and that side will become positive. Another temporary dipole is going to be produced. So it's not randomly dipoles will keep fluctuating. Maybe the electrons get knocked in this direction during a collision. So this side will become negative and that side will become positive. So they'll be fluctuating dipoles, negative and positive charges. So molecules will attract each other through van der Waals forces. That the negative side of one molecule will attract the positive side of the other molecule. But all these dipoles will be temporary, and that's known as van der Waals forces. Okay? They're very weak. So they've got weak van der Waals forces. उन्हें ये बात क्लियर है?
Yes.
अच्छा, अब ये हो गया physical properties, right? So that's your physical properties. Now, what is also important, the non-polar, so they're not going to attract water. So not soluble in water as well. But remember this thing, वो फिर से हम repeat कर लेते हैं. When the size of molecule increases, whenever the size of a molecule it increases, what happens? You have more van der Waals forces. Bigger molecules will have more temporary dipoles, so there's going to be more attraction, more van der Waals forces, which would result in higher melting and boiling points. Because of that, because since they're having higher melting and boiling points, what will also happen is that it will be thicker, more viscous, क्योंकि वो एक दूसरे को attract करेंगे, so they won't flow very smoothly. They'll be like a semi-solid. And bigger molecules will also be harder to burn because they're not going to mix with oxygen, because they'll be attracting each other very strongly. So they'll be less flammable as well. तो ये property याद रखना कि this applies to all of them. All organic molecules, ठीक है, this one. अब आ जाओ first reaction. अभी बस इतना ही टाइम है, first reaction का ना वो कर लेते हैं कि they basically just have one reaction, kind of one reaction only. The first reaction is known as free radical substitution. That's a free radical substitution. और इसमें क्या होता है? Free radical substitution. That's the main reaction. In O levels, you studied this. You call this halogenation or chlorination or bromination. या फिर chlorination. और प्रोमिनेशन भी इसी को कहते थे। ठीक है, और simple substitution. What would happen in this reaction is that you'll have an alkane with hydrogens, और इसको ना आप you would react it with Cl2. So you would react it with Cl2. They were, or Br2. There were specific conditions for this reaction. Ultraviolet light was needed or sunlight was needed. And that's about it. That was the only condition, by the way. So, and as a result, what will happen is that the H's will get substituted by chlorine. और वो जो H substitute हुआ है ना, that will also bond with chlorine, so it will form HCl. And it's not just one Cl; it could be any number of Cls. Okay, so you could have multiple displacement. So any number of Cls could be involved in the substitution. So you might have, and it was a random reaction. You can't really predict where the Cl is going to get attached. So, for example, in this one, you're having three Cls substituted. So many random substitution products are possible. Clear है ये reaction याद है O-levels का? Is that clear?
जी सर।
Yes, sir.
अच्छा, तो यूवी लाइट और ये सब। अब इसमें ना एक मसला है कि वैसे तो यही है बस, दैट्स द रिएक्शन। ठीक है, आई जस्ट गिव यू सम अदर इंफॉर्मेशन दैट the same reaction, the substitution reaction, can happen with any alkyl chain. ठीक है, so the reaction is not just for alkanes. Reaction can happen with any carbon chain. Now, almost all molecules have a carbon chain. Alkyl chain जो होती है, that's a carbon chain. ठीक है, so you don't need an alkane, by the way, for this reaction. You can also have, because any carbon chain, it kind of looks like an alkane. वो तो बीच में एक functional group आ जाता है ना. So if I have a carboxylic acid, तो ignore the carboxylic acid, उसका ये वाला part that definitely looks like an alkane, right? So that will also undergo this free radical substitution reaction, again with ultraviolet light. तो उसके अंदर what will happen is that अगर ये propanoic acid था ना, then what will happen is that randomly some of the H's will get substituted by Cl. Or HCl would be your byproduct in this case. ठीक है, so is this also clear that it can happen with any carbon chain?
जी सर।
Not limited to alkanes. तो बस अभी तो फिलहाल यही है ये इसका ना. फिर अब इसका जो इम्पोर्टेंट चीज है ना, वो ये कि नेक्स्ट क्लास वी लर्न, तो कल ही करते हैं, नेक्स्ट क्लास वी लर्न के हाउ डज दिस रिएक्शन हैपन. अब आपकी जो ऑर्गेनिक केमिस्ट्री है, दैट्स लाइक वेरी सिमिलर टू O-levels ऑर्गेनिक, except for this fact कि O-levels में ना you would just study this thing, that's it. But now what you will study is कि why does this reaction happen? What's the reason for this reaction? What are the steps involved in this reaction? So we're going to go and take a deep dive into this. Overall reaction, yeah, that's it. That's the same O-levels reaction. पर वो फिर अगली क्लास में ना इसका पूरा मैकेनिज्म जो है ना, कि why does this reaction start? What does the UV light do? ठीक है, what happens after that? What happens in the second step? What happens in the third step? तो वो सारा डिटेल में ना we'll do it in the next class. ठीक है,
ओके सर।
चले, ओके.
सर कल क्लास किस वक्त होगी?
कल जल्दी कर लेते हैं, अगर अगर तो 5 कुछ हुआ, 5 कर लो, 5।
पाकिस्तान
हाँ,
टाइम।
पाकिस्तान टाइम, ठीक है।
ओके।
चल, ओके, अल्लाह हाफिज।
अल्लाह हाफिज़।
Sir,
जी,
uh, the 5 p.m. is Pakistani time, is it, sir?
यस, 5 PM पाकिस्तान टाइम।
Uh,
You have a class?
so, yes, sir. Yes, sir. Physics class starting at I think it's 5, exactly 5 there.
अच्छा, how about I can't do
It
after.
goes from 5 to 6, sir.
It's 5 to 6. ठीक है, what I can.
Mm-hmm.
So I'll ask if 6 to 7 is fine.
Mm-hmm. Okay, sir. Thank you, sir.
चलो ठीक, okay.